So, Jai Hind everyone, I am Ankita Sharma, working here in Ajay Kumar Garg Engineering College as an assistant professor in ECE department. So, today I am here to cover the complex topic number 2 of the subject microprocessor and microcontrollers. Subject code is BEC 502, and today we will be covering the topic which is a very important topic in every exam, in every paper of your STs, in your PUTs and in your UTs also. You can find a question on memory interfacing in 8085 microprocessors. So let's start. So first of all, what is a memory interfacing? When we have to interface the memory with the microprocessor, then the interfacing is required. What is interfacing? So interfacing is basically a way of communicating. For example, microprocessor wants to communicate with the memory. So we have two types of memory here in microprocessor. One is ROM and one is RAM. So these two memory chips will be used as the interface which we'll use to interface with the microprocessor. So the memory interfacing in 8085 is used to access memory quite frequently, and we use it for read instruction codes and to write also. The instruction codes are stored in the memory and read and write operations are done, and these read and write functions and operations are also the control signals of the microprocessor 8085. So basically in microprocessor 8085, as we all know, there are three control signals. One is read, write and input-output memory. So input-output memory is the pin which decides from which the microprocessor will interface. Is the microprocessor is interfacing with input-output or the microprocessor is interfacing with the memory. So here in this topic, for that in IO / M bar. So this is the pin which is used to interface with processor IO / M bar. So here we are interfacing with memory. So this pin will be permanently active low. Active low, why? Because there is a complement sign in the memory. So that is why this will be active low, and two control signals will be there which will lead to some operation, that is read operation and write operation. So if I have to read from the memory, then the control signal memory read will be used, and I have to write from the microprocessor to the memory, then it will be memory write. So these two control signals will be used according to the memory. For ROM, we will be using only read because it is read-only memory, and for RAM, we will be using read and write both. That we will discuss with some examples from the university papers itself. So while interfacing, there are a few basic things that we need to cover. So I am just putting these things in 4 categories, or I can say these 4 steps are a must when you are attempting the question of memory interfacing. So first of all, how many different memories are there to be interfaced? Is only RAM is given or ROM is given, or both the memories are required? So we have to interface either with RAM or with ROM, and with both also. In a single question, in a single memory interfacing, we can interface microprocessor 8085 with ROM and RAM both. So there are 3 types of questions from memory interfacing where you have to interface RAM with microprocessor, first thing. Second thing will be, we will be interfacing ROM with microprocessor, and third will be, we will be interfacing RAM and ROM both with the microprocessor. So this is the very first thing, how many memories are required. Second thing is how many address lines and data lines. As we all know, 8085 microprocessor. 8085 microprocessor is an 8-bit microprocessor. What does 8-bit signifies here? 8-bit signifies how many bits can be transferred in a single cycle. So 8 bits, that is why the data bus is of 8 bits. So the data bus here, or the data lines we can say, they are fixed for all the memories. For RAM, ROM and any other interfacing, data lines are fixed because microprocessor 8085 is an 8-bit microprocessor. Clear? So here we are having 8 data lines, and how many address lines are required? That depend on the memory on which we have to work. For example, The memory given is of 1K. 1K memory is given, for example, and we know 1K, if I write 1K in terms of 2 raised to power, it will be 2 raised to power 10. So 2 raised to power here, this 10. This denotes the number of address lines required. So as we all know, total number of address lines are 16. In microprocessor 8085, there are 16 address lines, that is from A0 to A15. These 16 lines are there. These 16 lines are here. So out of these 16, 10 will be used if the memory is of 1K. So this is the address, number of addresses, how many addresses are required. Next thing is how many control signals are required. So control signals are read and write, and if I am reading, it will be memory read. If the microprocessor is writing, it will be memory write. So one more thing we will see here. When we will discuss the example, the number of steps will follow, and last but not the least and the very important thing is chip select. So chip select can be denoted by CS bar. It is also an active low signal. So when the chip is need to be interfaced with the microprocessor, it needs to be select. For example, I am having 4 chips and I want that particular chip to interface with the microprocessor. Then what is the criteria? What is the procedure by which I can select that particular chip? For that, there is the pin. It is chip select. So this chip select will be there in the ROM or RAM itself, as we will see in the next slides. So this will be the final model which we'll be getting. But here, this memory interfacing shown is for 1K memory byte. 1K memory is here. Here we can see it is the microprocessor, address lines are there, data lines are there. A latching is also done with the help of a latch and pin ALE. Why the latching is done, all these things will be discussed now. Here are the control signals, only 2 signals are there, memory read or memory write, because microprocessor can memory read or memory write. And next will be our IO read and IO write also here. So let's take an example and let's start with the first example, that will be for simple RAM and ROM. And for that, I'm just writing the question here. Example number 1 will be my draw the interfacing I'm taking 2 examples for RAM and ROM both. So draw the interfacing, or to interface 8 KB EPROM and 16 KB RAM. With 8085 microprocessor, MUP, using the decoder and using 8 KB of RAM here. Using 4 KB of EPROM, 4 KB of EPROM and 8 KB of RAM. Also show the decoding for the chips. So in exams, these kind of questions generally come. So we have to interface both RAM and ROM both. So I am covering here the typical example that generally comes in university exam also, SC and PUTs also. So if we see here ROM and RAM, we will be covering these two memories. So all the conditions have to be satisfied here. For that, the very first thing we have to see what the memory is given and what kind of memory is expected to be interfaced. So here I have to interface 8 KB of EROM. Simple, 8 KB of EROM and 16 KB of RAM. But there is a twist here. It is given using 4 KB of RAM. So I have to interface 8 KB of EPROM using 4 KB. That means I will be using 2 chips for EPROM, that is 4 KB and 4 KB. So we can write it like this also. For 8 KB, I will use 2 KB of EPROM, sorry. And for 16 KB like this, there will be 2 8 KBs. Of RAM. So 2 chips here and 2 chips of RAM. So total 4 memory chips are required here. 2 for EPROM and 2 for RAM. So very first thing for the solution is for 8 KB EPROM. Number of address lines will be different for RAM and ROM, as we can see. It is 4 KB and it is 8 KB. So what we will do for 8 KB EPROM, what I am going to do, for 8 KB EPROM, I need 2 chips, 4 KB, 4 KB. Simple. So number of chips required are 2 chips are required. Next thing is my address lines. Very first thing, how many address lines are required? So address lines depends upon the 4 KB. 4 KB I can write 4 multiply 2 raised to power 10 because it is KB, 1K, and 4 can be written as 2 raised to power 2, 2 raised to power 10. Base same, powers will add, it will be 2 raised to power 12. So number of address line is 12 here for 4 KB. One thing. Next is, second point is number of data lines. As we all know, it is a microprocessor 8085. It is fixed. The number of data lines are fixed. 8 data lines, that is fixed. Next is my control signal. Control signal totally depends upon what kind of memory are we using. Here I am using ROM. ROM is read-only memory. So only memory read signal will be used. So it will be memory read. It is an active low signal, that is why it is written here. I can also write it like this. For more clarification, memory read. So this is for 8 KB. Now for 16 KB RAM, all these 3 points again required. RAM is having 8 KB, 8 KB. Number of chips required is again 2. First thing is required here is again address lines. How I can write it? So 8 KB can be written as 2 raised to power 3. 8 KB can be written as 2 raised to power 3 multiply 2 raised to power 10. It is 2 raised to power 13. So this 13 is my address lines. So how many address lines are required? 13 address lines. Here 12 address lines were there. That means from A0 to A11 address lines will be used. And I am saying 13 address lines means from A0 to A12. Total number of address lines are 13. Next, second point is my data lines. Data lines are same. For all the memory chips, the data lines are same because it is an 8-bit microprocessor, only 8 data lines can be used. Last is my control signal. As we all know, RAM is random access memory, and for RAM, it is also known as read-write memory. RAM is also referred to as read-write memory. So the control signals will be memory read and memory write. So the control signal here is, if I talk about the control signals, it is MEMR bar MEMW. It is memory read and memory write. So memory read, memory write. These are the requirements that I have done. Next thing is memory mapping, which is also very important thing. Here generally students get confused about the memory mapping. It is very simple and we will do it by simple steps by steps. As we all know, how many address lines are there? There are total number of 16 address lines there in 8085. For that, we will make a table here. So this is memory chip. So how many chips are there? I have total 4 chips. EPROM 1, EPROM 2, RAM 1, RAM 2. These are of 8 KB. These are of 4 KBs. Sorry. Draw a partition here for the address lines. In exam also we can do like this. Next is how many address lines are there? Total 16 address lines. So I will be writing all the address lines from left to right. Sorry, from right to left. So it will be, here I will be writing the memory address. It will be A0. I can do 4 partitions also here for the address lines. All the address lines also can be classified in 4 groups: A3, A4, A5, A6, 7, 8, A9, A10, 11, 12, 13, 14 and 15. Now, for the memory mapping, the very first thing is how many address lines are required for that particular memory chip. So we can see it from here. Total 12 address lines are required for EPROM. So I need 12 address lines. So 12 address lines. For example, the starting address is 000H. As it is a 64K memory, all the bits are, all the address is 0. So I can mark 0 here. All the address lines are carrying 0. Next thing, how many address lines are required in EPROM? Total A0 to 11, 12 address lines. So what I am going to do, I will mark from 0 to 1 to, from A0 to A11. All these 12 lines will have 1. A transition from 0 to 1, because for EPRAM मुझे कितनी एड्रेस लाइंस चाहिए? आई नीड 12 एड्रेस लाइंस. तो 12 एड्रेस लाइंस जो मेरे पास है, आई एम हैविंग 12 एड्रेस लाइंस फ्रॉम A0 टू A11. मैं 0 से उसको 1 लिखूंगी. वाई? बिकॉज ओनली दीज 12 address lines are used for interfacing EPROM. This is the only reason, and you have to remember this. Next, these address lines are not used for ROM. So I will write it as it is. 0 will be marked as 0. So 0, 0, 0, 0. Now these binary numbers can be written in hexadecimal number. 11111 is F. It is also F, F, and last is 0. So this is the memory address from 0000 to 0FFH. This is for chip number 1. For next chip, again it is EPROM. How many address lines are required? Same again, 12 address lines are required. Now, I will not be writing 0000 because I have used that address already in ROM chip. So what I am going to do, I will just increment from 0FFF. One increment will be there. After F, it is 10. So 0 will be here. So it will be, the address will be 1000H. So 1000 is in hexadecimal number. I can write this hexadecimal number in binary number. So let's write in a binary. So 0 is written as 0000 in binary. And 0 in hexa will be written as 011110001. Now again, how many address lines are used? 12 address lines from A0 to A11. All the numbers from 0 to 1 will be here. 0 to 1. From A0 to A11. जहां तक एड्रेस लाइंस मेरी यूज हो रही हैं हम उसको 0 से 1 ही करेंगे. Only those address lines that are we'll be using in ROM. Next is now. Am I using these remaining 4 address lines? No. EPROM is not using these address lines. What will happen? The value will remain same. Here the value was 0, that is why 0 was written. Here the value is already 1. So I will write 1 like this. Now this binary number can be written in a hexadecimal number. It will be 1FFH. Next is for RAM. Now for RAM we know that 13 address lines are required. It will be from A0 to A12. These address lines are covered in ROM. This memory address is also covered in ROM. What should I do? I will again increment. I can take from 2000 or it is my wish. I can take 4000, 6000, 8000. It is totally my wish. But I am just putting it in a sequence. So I can take 2000H. Why? Because these address are already used by ROM. That is why. So 2000 can be written as 0010. In hexadecimal number it was 2000. In binary I can write it like this. Again, for 8 KB, how many address lines are required? 13 address lines from A0 to A12. So till A12, all the zeros will become 1. Till A12 only, because 13 address lines. So 1 will remain same, 0 will remain same. This. So 0010, 0011 is 3 and remaining is F. So this is the memory mapping for RAM 1 and for RAM 2 after 3FFF it is 4000. अगर मैं इसमें +1 करूंगी तो 4000 आ जाता है. 0 0 0 0 0 0 0. Now next is 4 is 0 1 0 0. 13 address lines from A0 to A12. So till A12 numbers को हम 1 कर देंगे. And we will put the numbers as it is. Remaining numbers will same. Remaining will be same. Like this. So this is 5FFF. So 5FFH. So this is the range for EPROM 1, 2, RAM and RAM 2. So this is very important. This memory mapping is very important for the architecture or for the structure we have to make for the interfacing. If there is a mistake in memory mapping, you cannot select the chip because the remaining chips will be having the remaining address lines as their input. So this is a very important thing to do and it is very easy to map. Number of address lines that are required, simply put from 0 to 1, and the address lines which are not used, 0 will be 0, 1 is 1, 2 is changed because 13 address lines are there. So I hope this memory mapping you can done very easily. Next is the diagram, the very most important thing. For that, one thing is required, that is my microprocessor. This is my microprocessor 8085. Next thing, what I need? I need lines, address lines and data lines. Data lines are fixed, but one thing, data lines are multiplexed with address lines, that is ED0 to AD7, AD0 to AD7, address data line, address data line. I have to demultiplex them using ALE. ALE की value अगर 1 है, then address will go, and if the value of ALE is 0, data will go. This we have learned in the last lecture also, in the architecture also. We have covered these small things regularly in the class also. So address and data lines. So I need ALE pin also. So ALE is required, 10. ALE is required here. Next is address lines and decoder. I will need a decoder for the control signals. So here is the decoder. Here is the decoder. And next thing is my inputs for the decoder. So the input for the decoder can be the signals. Three inputs for the decoder, that is read and write signals. So read and write signals will be used for the decoding this particular signals, for read signal and for write signal as well. So here this is my 3:8 decoder. Now this is my latch. Latch needs ALE. Here address lines are from AD0 to AD7. From latch I will have A0 to A7, and without latch I will have data lines. So I can put these data lines like this in an arrow. These are my data lines, and with this latch I can have my address lines, and remaining address lines will be here from A18, A8 to A5. I can do one thing. Here two things can be done. Either you can draw remaining 8 address lines individually, or you can just combine them using this unidirectional arrow. So we are just drawing 8 lines because I have EPROM and EPRAM and ROM both. This is a very important topic. 7 and last is A15. So this is A15 and A8, 9, 10, 11, 12, 13 and 14. These address lines. Now what is required? Inputs, read, write, input output, memory bar. We can say ABC. 8 outputs are here. So these outputs, out of all these outputs, I will need only 4 for memory read and memory write. Here for memory read it will be Y1, and for memory write it will be Y3. So total number of chips required is 4, 2 EPROMs and 2 RAMs. For EPROM, RAM, EPROM and RAM. So this is ROM 1, ROM 2, RAM 1, RAM 2, chip select. I am just drawing this 4 ROM and RAM in the next page because it will not be visible from this side. So this is my ROM, ROM 2, RAM 1, RAM 2. So I need total number of address lines. How many address lines are required? For ROM, it will be A0 to A11, and I can put these address lines here also. And these address lines I will connect from this and above address lines also. Similarly, this will go here also. Address lines A0 to A11. Next is ROM is a memory read signal. So my signal is read bar, write bar, only memory read will be required. Read bar, write bar, memory read will be here. For RAM, read and write both are required. Memory read and memory write both. We can put the value of the decoder's output also here, that is Y0 bar. I can write it also, Y0 bar and Y1 bar also. For Y1 bar it is memory read and Y2 is for memory write here. Here it is chip select. What is the role of chip select? Chip select will be having all the address lines that are unused for ROM and RAM. Suppose for ROM it was from A12 to A15, these 4 lines were not used, and in RAM it was from A13 to A15, three address lines were unused. So all these 3 address lines will become the input of the chip select. How? A NAND gate will be connected here, and this NAND gate will have an input all the address lines which are remaining, 13, 14 and 15. So just like all the other will be connected as well. This memory write will be connected in ROM, here also in ROM. Memory write will be connected in the RAM, here also in the RAM, and memory read also, like this and like this. So this diagram can be completed with the help of these things. And one more thing, data lines will also be there. 8 data lines are there. So these data lines, just put 1 mark here for the data lines and put a bubble here so that all the lines can be connected, just like this. This is my enable, data enable, enable. This is my Y1 bar, Y1 bar. This is Y1 bar and 2 bar, 2 bar. So these 3, and this is the latch. Latch is generally used for demultiplexing of the lines, and all these things will be used for the memory interfacing here. These are the 4 chips that we will use for ROM and RAM. ROM 1 for these 2 will combine and connect my 8 KB of EPROM, because this is of 4 KB, this is also 4 KB. RAM individually is of 8 KB and 8 KB, and when I combine it will give 16 KB RAM interfacing here. This is the memory chip value, and now the remaining address lines will give the input for the chip select. A NAND gate will be connected on the chip select's output, and all the remaining address lines will become the input for that particular NAND gate. And we all know NAND gate requires all the zeros for the input, and for that all the address lines will be connected here, and the output of that particular NAND gate will be used as the input for the chip select, and that chip select will particularly select that particular ROM or RAM from which the memory interfacing will be done. And this is the very important, this is a very important topic, and I hope this type of question can be solved easily after this. And these are the basic steps which we have covered. This is the memory mapping and the final diagram here. These are the references, and the book is Ramesh Gaonkar, which we have followed for our text. It is our textbook. And, yeah, thank you.